All right, we're back. It's COMP228's week 5, lesson 5, part 2. We just talked about a really high-level demo of inheritance and how to do it, and it's really, really simple demo that we did. But we use two things. We use inheritance, right? And we also use composition in order for us to put these two classes together, or these three classes. Actually, we have, if you notice, look, we have our driver class, our person class, and we also have our program, which is our driver, resident class, which is our resident. It's the subclass of the person class. And we use the address class to compose the resident class. And we could have done it, we can go even further and use some kind of other thing to compose the address class, like, for example, different provinces. We could have made that too. But we're not going to go there. Let's go into right-click here, and we're going to go to team, and we're going to go commit, and we're going to say updated program, driver class, and resident class. Actually, we added a little bit of exception handling, commit and push. Okay, so we've done this. We're good to go. Let's take a look at some of the stuff that we talked about in the PowerPoint, and I'll run you through it really quickly. Again, we use the extends class, the extends keyword, just as a recap of what we did. Right? We use protected as a modifier so that the superclass can pass on its private instance variables to its subclasses. Right? That's one thing that's important here. Again, there's other things you can do with protected and private. One thing to note is this question. We did a resident. If I want to make a student, which I'm going to do tonight, right? I'm going to make a student and a teacher, right? They're both residents. Should I make my resident social insurance number and address, should I make them private or protected? The answer is protected might be the better choice if I want full access. If I don't care about being full access, then, or if I want to hide something, maybe I want to hide some stuff from my, it's appropriate to hide stuff from my my lower class, my subclass, then I make these private, right? And then it won't be accessible to my my subclass, the subclass of the resident. Even though resident is a subclass of the person superclass, and person is a subclass of the java.lang.object superclass, right? Resident can further be a superclass of the, we're going to make a student subclass, and it could also be a superclass of the teacher subclass, right? Because student and teacher could be different subclasses of the resident superclass. So you could have a series, a hierarchy of superclasses and subclasses all the way down, plus an additional other classes, helper classes like the address class, which is used for composition. All right. This is all covered here in your PowerPoint. So if you go down, we talked about inheritance. You guys all know this from C#, so I'm not going to go into what the difference is between a superclass and a subclass. Here in Java, it's called subclass. And sometimes you also see them called parent classes and child classes. That's also sometimes what we hear. There's other names for superclasses and subclasses, right? What are the other names that you could possibly have in other languages for superclasses and subclasses? What are they called in C#? Parent class and base class, base class and subclass, base class and child class. There's different names for them and different things. They mean the same things. I may test you on it and say another name for for a superclass is a parent class. I might ask you for that kind of thing in a simple test, that kind of thing. Okay, as we go, there's one thing that's called the direct superclass. There's a direct super. What's the direct superclass? All of these are superclasses, right? If I have a resident, the direct superclass of resident is the person class, and the direct superclass of person is the object class, right? The java.lang.object class, right? What about resident? Is resident is the superclass, the java.lang.object class, the superclass of resident? The answer is yes, right? It's still a subclass. Resident is still a subclass. All objects, all classes are subclasses of the java.lang.object superclass, right? But it's not the direct superclass. The direct superclass means the one that spawned it. Where I see the extends keyword here, person, the person is the direct superclass of the resident subclass, right? Even though it's still a subclass of the java.lang.object superclass. Whew. So just in case you hear direct superclass, that's what we need. And this is an indirect superclass means something in the hierarchy. You have something up the chain that's more of a further up, and that's the example of that. Okay. two things we know is we're going to talk about an is-a relationship. An is-a relationship. So when I say a resident actually is a person, right? Just like a person is a object, right? They have that relationship. And if I have composition, here's a composition example, right? The resident has a address, right? But the person, because it's so generic, doesn't have a address, may not have an address. It could have a person who doesn't have an address, who's homeless, right? That's a person, that could be a subclass of the person superclass, right? Homeless person. That would be bad, right? We don't want those people in our society. We want to help them as much as possible, but we have those. That is a reality. So if we were going to classify society with classes and objects, right, then certainly there could be non-residents, and certainly there could be residents that don't have any addresses, right? So therefore, HAZA it represents composition, something that you enjoy, an object that is part of our class. Okay, let's take a look at here. So, and we have examples of students and shapes and loans and employees and so on. But this is something neat that you should look at as well, this hierarchy, right? So we have a community member. That's, everyone here is a community member. I just call it residents. Then there's an employee, and there's faculty and staff. This is kind of what I create later on with a teacher and an administrator. This is actually right in the book. There's also a student, right, and an alumnus, right, which is different than a student or an employee, but they're all community members, right? Community member would be the superclass. Employee, student, and alumnus would be subclasses. And further down from employee, subclass of employee would be faculty and staff, and subclass of faculty would be administrator and teacher. So you get right to teacher, which, if you notice up the chain, is still a community member, but the direct superclass of teacher is faculty. Direct superclass of faculty is employee, one up the chain, right? This is a great example of how this works. Okay, so I'm not going to talk too much about the shape of inheritance. There's a shape. Here's another example of shape with a two-dimensional shape and a three-dimensional shape. That's two options. And a two-dimensional shape is specialized. There's just two dimensions, circle, square, and triangle are example of those. And where a three-dimensional shape is sphere, cube, and tetrahedron, right? So those are the example of is-a relationships. All right, further down as we continue, HAZA relationships, we talked about having an address, right? Protected members, I recommend those if you want to have access, if you want to provide access to your subclasses, to the private instance variables in your superclass, you want to use the protected keyword. If not, you may not use that because there might be some private instance variables you want to keep separate from your subclasses, and that's okay, right? Because private members are accessible only within the class itself, right? Keep that in mind. All right. Protected members are also available on the package level. Let's go back to, we talked about relationship between classes and subclasses, superclasses and subclasses, and there's some really nice examples here in the book that I'm not going to cover about, you know, an example about a superclass and subclass. And here, look, I use the override, the @override decorator. Hear me out, decorator, right? That's what it's called. Above the public string to string method that we overrode. That's what they overrode. I use an output string. You can certainly use string.format. That's the other option they show in the book. This is another really great way of formatting your string on output, right? Nothing's wrong with this method. In fact, I would recommend something like this, or even the way I did it, right? Okay, so I'm not going to go into more detail. Again, a lot of these slides that you're going to see here in your PowerPoint support what we've been doing today, right? And they give you an example of making a subclass or base class of these things. I'm just going to see if there's anything else that I want to cover before we end for this morning, right? But I think we've covered most of it that you should know and that I'm going to be testing you on, right? One thing is that's one thing. The superclass, we need to, just like we did here, one thing to note as a syntax, right? I went and created the resident class, which is a subclass of the person superclass, and I needed to, in the constructor, I needed to have a constructor because it's a subclass, and I needed to call the in the constructor, the first thing I did was call the super constructor, right? The superclass's constructor. And the reason why I did this is because it's required, or else you're going to get a compilation error, right? You need to send the information of this to the superclass so that it's satisfied, right? If it's not satisfied, you can't create your subclass. And what's the word that we use instead of super for C#? The comparison. What word do we use there? Base, right? We use base in our constructor. to access the constructor of the superclass. And we don't use extends, we use the colon, right? The colon in C# extends this, the current class from the superclass, right? That's the only differences that we see there from a syntax perspective. All right, let's continue. So that's really in a nutshell. From this, there's again a bunch more examples, which you should probably look at as an example of the way they've done it here in the book. I'm not going to be testing you on the book's examples. Getter and setter methods become really important when using inheritance, just like we showed you, where there's a need to have more of a read-only getter. For example, if I want to read the SIN number, I can never set it again. That's a good example of a getter only, a read-only get accessor method, as opposed to a read-write getter and setter. Kind of that binary pair that we're talking about here, right? Those two things, right? So we don't have to use those two things. All we need is a getter, a read capability for particular private instance variables that we're going to use. Again, best practices, private instance variables, public getters, and setter methods, right? So that way we can access our private instance variables. They remain secure. And that's really it in a nutshell. I don't think there's anything else. One thing I should probably point out, actually, before we go, is there's at the bottom of this PowerPoint, they explain the generic superclass methods that you should probably know, right? For example, equals, hash code, what they do. We also have a toString method, which we're going to override a lot in this class, right? We also have some other things like finalize, right, which we're going to talk about as a garbage collector. That's part of our class as well. And then finally, we have something called clone, which we can use as well to create a shallow copy, right? Again, the most important one is that I would recommend is to know is definitely the toString method, which I will make you know on an exam, especially if you're going to do something practical. The toString method we're going to override a lot, so please understand how to do that. Remember that it returns string. And that's it for me for now, and we'll meet later on at 6:30. Questions before we go? She's shaking her shoulders. I'm just looking at Ravina because if anyone has questions, how about Tim? Any questions? Tim saying no. Tim saying, Tom, you bored me enough today. I want to go, right? I want to eat now, right? Okay, let's go eat and all that kind of stuff, and we'll meet later on.